Welcome to 7.1, operations on functions. So we're going to use two functions and we're going to perform basic operations with them. For example, if I add them, let's use colors too to help. So this is my red function and this is my blue function. If I want to add them, I'm literally adding like terms. So I have x squared minus 7x minus 8 and I'm adding x plus 1. So as I combine those like terms, I can see the result is x squared minus 6x minus 7. If I'm subtracting, same idea, just make sure I subtract the whole thing. So I'm going to take my red polynomial, x squared minus 7x minus 8, and I have x plus 1. Now the only difference is kind of like when we did long division again. Make sure you subtract that, right? So I'm going to have x squared. Negative 7x minus x is negative 8x. Negative 8 minus 1 would be negative 9. Again, we're not asked to factor or do anything with them. We're just asked to combine like terms. Okay, so don't do too much work. Multiplying. Got to make sure I can still see those polynomials though. So if I want to multiply them, I need to multiply x squared minus 7x minus 8 times, x plus 1. So first thing I'm going to do is I'm going to take each of these and multiply them times x. Kind of think of it like distributing from the small guy. So I have x cubed minus 7x squared minus 8x. And now I'm going to do everything times 1. And I like to put them underneath each other so I can kind of see and combine them later easier. So I have x squared minus 7x minus 8. I'm combining like terms, so I get x cubed minus 6x squared minus 15x minus 8. Now dividing. Dividing is one that can sometimes cause some problems. So dividing, let's see. I'm going to take x minus 7x and I need to put it over, literally divide, by x plus 1. Sorry about the colors there. Let's make that blue. Okay. Now first thing I actually need to do with the division, because there's a polynomial in the denominator and it might disappear, hint hint, I need to include what I call a but statement. So I say but, I need to ensure the fact that there cannot be a 0 in the denominator. The only way there would be a 0 in the denominator is if x equals negative 1. So I'm writing it now so I remember to include it later. So I'm going to check, can I factor this? Can I factor this? Oh, I think I can. I think I remember that this is x minus 8 and x plus 1. So notice it cancels out. So my solution to this is just x minus 8. But I need to be careful because I still have to be, that value would disclude this whole polynomial. So I need to make sure I include that statement in my as part of my solution. So anytime there's a polynomial in a denominator, I need to do that. Be really careful as you do some of the homework. I know there's ones where you're going to have to think about adding and subtracting fractions. Remember, you need like denominators, so it might get a little messy, but see if you can work through it, and we'll talk about it the next day if you get stuck. Let's talk about some other important stuff you might not have seen before. First thing is this circle function. We're talking about composition functions. They're slightly different than normal functions. Composition functions use the output from one function as the input for the next function. And they're typically written like this, or as a nested function. So we're going to figure out how we can use this information to help us do this problem. One thing that helps me is this circle function sometimes confuses me. It's actually easier for me to think of it this way. Because this way I know I'm going to work on this inside part first, right? Like the innermost parentheses, like in order of operation. So what this means is I'm going to start with something from G. So for example, let's say I took the first point, 4, 3. And I want to see if I can take this end result, this 3, and link it to something in F. Why, yes, I can. Because I can take this output from G and link it to this input in F if you look at that first one. So the result here would be 4, negative 2. Let's see if we can do it with another one. Let's say I took the second one in G. So again, these are my G functions. These are my F functions. So I'm trying to link G to F. G is inside, that's why I start with it. So -1, do I see that in the domain for f, in the x values for f? Oh, I do, right there. So I see -1, -5. So the result here would be 2, -5. And we keep going like this. So we have 9, 4, and that links to 4, 7. And so that gives us 9 and 7. So think about it. Where do I start and where do I end? That's what I'm writing as my result here. The other one's just kind of like the connector. So think about, like, you're taking an airplane flight across the country. So you start in San Francisco, you connect in Dallas, and you end up, I don't know, in New York. So in the end, I really started in San Francisco and ended in New York, but I needed the same connector. It's not going to be good if I go from San Francisco to Dallas and then they're trying to give me a flight from Chicago to New York, right? I can't make the connection. You need to be able to make the connections. So the last one here would be 10, 8. Oh, I apologize. Let's make sure I'm using my g functions, not my f functions. My last g function will be 3, 10, and that links to 10, 3. And so my result here, I started at 3, I ended at 3. So this would be my f circle g here. Where did I start at the very beginning? Where did I end? Using my pass-through, whatever was in the middle here. Get it? I know it's kind of weird. Listen to it again if you need help or ask me the next day. G circle f. Again, this means I'm going the opposite way. So this means now I want to start at the other end. So I want to start saying New York and I'm going back to San Francisco, and can I get a good connecting flight? I don't know, something like that. So let's say I started with some f function, 3, -2. And so I look, is there any domain in G? Is there any starting x value that has -2? And I go, uh-oh, I can't connect. Saying x, like I can't do it. Okay? And then I try the next value of f of x, which is -1, -5. And I look for -5 in the G, and again, nothing. Okay, and then I tried again with 4, 7. And I tried again with 10, 8. And I notice that nothing connects. I'm stuck. I can't make it back. So, what's the answer to G circle F? It's the empty set. There is no connection back. Now, sometimes this was kind of a case where everything connected or nothing connected. Sometimes only 1 or 2 will work. So do whatever works. Those are the connecting ones to make to the last one. So let's see if we can kind of apply this to some numbers down here. It might make a little more sense even. So if I do m of n of -3, that's kind of the way you say it with these ofs too. It means I start in the middle and I want to find n of -3. So I'm going to use this n function and substitute in -3. So if I do that, I'm going to have -3 squared plus 2 times -3 plus 3. So m of 9 minus 6 plus 3. So really what I'm going to end up finding is m of 9 minus 6 is 3 plus 3 is 6. So now we're going to find m of 6. We just take our steps. So we started at -3. Our connecting flight is 6. Let's see where we end up. So if I plug this into the m function now, I get 6 minus 5. So my end is at 1. And again, when I'm doing these types of problems, I only care about what is my end result. So I started at -3, I connected through 6, but my result was 1. Let's try it again. This time I'm doing n circle m. So notice I'm going in the opposite direction. Do you think I'll get the same result? Let's find out. So again, I'm doing n of m of -3. So n. Let's see, m, oh, that's a nice easy function, I like it. -3 minus 5. -3 minus 5, oh yeah, that's -8. Now I need to plug that in the n function. So that's -8 squared plus 2 times -8 plus 3. So that's going to end up equaling 64 minus 16 plus 3. Let's see, sometimes I like doing the positives first because that helps me add easier. So that would be 67 minus 16, and we get 51. Wow, that wasn't even close to the same result. Here we got 1, here we got 51. The order really was important. Let's see what happens if I do the same function twice. Interesting. So this means I'm going to plug -3 in for the n function. Hey, didn't I I do that already? Oh yeah, we did that for the first one. And what was our result again? Oh yeah, we did all this work and we found it was 6. So I'm going to cheat a little bit. I'm going to use that information and say that I know this is the same as n of 6. Now that doesn't mean necessarily I'm going to get the same result because I'm not plugging it back into m. I'm plugging it now into n. So I'm going to have 6 squared plus 2 times 6 plus 3. So I'm going to end up with 36 plus 12 plus 3. 36 plus 12 would be 48, 49, 50, 51. Interesting that these two are the same. Do you think they'd always be the same? Nah, it just happened to be that way. So hopefully you get the idea with these circle functions. Make sure you start. If you want to rewrite them, you can. If you don't want to, you don't have to. But make sure you kind of work them backwards as one of the main things. Think about where you're connecting in the middle. Remember on the front page that when we did the operations that if you divide by a polynomial that you don't forget those but statements. And other than that, hopefully you'll have some success here and I'll help you in class if you don't. Have a great day.